Hello everyone, a very good evening. So I hope I'm audible and visible. If not, any one of you can confirm it. So we will start the session within 5 minutes. Yeah, good evening. We'll start the session within few minutes. Okay. Okay, everyone, so let's start the session. So, hello everyone, a very good evening. Yes. Okay, I am whether I am audible and this visible. Are you able to listen me? Okay, thank you. No problem. So you can message, you can message here whatever you want to ask or something. Okay, okay, okay. Okay, so my name is Pooja Verma. I'm PMRF Research Scholar from IIT Kharagpur and instructor for this course is Professor Jayanta Mukhopadhyay, Department of Computer Science and Engineering, IIT Kharagpur. This is a week 9 live and interactive session on computer vision, where we will solve some problem which will be similar to your assignment question. So it will be helpful to solve your assignment problem. Okay, so I hope all of you have gone this week video lectures. So here I am not going to the theoretical concepts. I will solve some numericals directly. I hope all of you have gone to the video lectures as well. So the course content for this week is range image processing, and you must be have been studied different range image processing techniques and their application. Okay, so we will moving to the questions. So our first question is choose the correct option. So option A is 8 illumination label are used in binary coding. Option B is n patterns must be projected in order to encode 2 to the power n strips in space encoding, or option C is every encoded point in binary encoding is identified by the sequence of occurrences that it receives, or option D is every decoded point in space encoding is identified by the sequence of intensities that it receives. So which option is the correct? B and D. Okay, let's see. That's nice. Okay, so let's see the detailed solution for this question. So the solution, let's go through the options as well, then we will see which options are the correct one. Okay, so option E is 8 elimination label are used in binary coding. So in binary coding, elimination labels are restricted to only two labels, either on or off, or we can say bright or dark, or also you can say either 1 or 0, right? In binary coding, either it is 1 or 0, right? 1 that is on and 0 is off. So 8 labels would be corresponds to a 3 binary code. So for 8 label, at least we need 3 bit. Okay, 2 to the power n, right? For 8 labels, so it 2 to the power 3, it will be the equal to 8. So, but here binary coding, we need only 2 labels. So this statement is correct. So 8 elimination label are used in binary coding. So not a 8 for binary coding, only 2 labels are required. So this statement is incorrect, right? Now next statement is n patterns must be projected in order to encode to the power n strips in space encoding. So in spatial encoding or space encoding, or it is also said structured light techniques. So in space encoding uses a sequence of projected pattern to encode depth information. Okay, in order to encode the our find that our depth information, we use space encoding, or we are also using the sequence of projected pattern. So a very common method is that we will use, that is a binary encoding. So which project n patterns to distinguish between to the power n distinct strips or design. So here n is the different patterns or different number of total number of patterns, you can say that. total number of patterns will be the 2 to the power n. N is the number n patterns, how many patterns will be there. So this will allow for a unique code for each point on the surface. So for example here 3 projected pattern, so 2 to the power 3, so that is 8 total encoded strips will be there. Okay, so this is the correct. That means n pattern must be projected in the order to encode 2 to the power n strips in a space encoding. Okay. Now next option is every encoded point in a binary encoding is identified by the sequence of occurrences that it receives. So in binary encoding, a point is identified by sequence of binary digits, either 0 or 1. So as it received as a pattern that are projected on it. The word occurrences is vague. That means, but in the theory, it means whether illumination occurred one or not in each projection. Okay, but in the theory, it is means whether illumination occurred either one or zero. So this could be interpreted as a correct, but the wording is imprecise compared to option B. Okay, it is a not a precise that is sentences. That's why it leads to a incorrect. And next option is every decoded point in space encoding is identified by the sequence of intensities that it receives. Okay, so in space encoding, or we can say structured light decoding, is based on the binary sequence. Already we have seen that, and we have of intensities, that is either bright or black, or you can say that bright or dark also received at each project pattern. So yes, each point is decoded by its intensity sequence. This is also can be a correct, but though it is describing the decoded step, it is describing the decoded step. So that's right. So in the option C and D, the words are confusing. So, but the core principle is that a sequence of projected pattern, that is the code is used to identify a point, not just its co-occurrences and intensities. So the most technically or precise correct option is option B. That is, n patterns must be projected in order to encode 2 to the power n strips in space encoding. So only option B is the correct answer for this question. Okay. Okay. So are you able to hear me?
Yes, ma'am, I can hear you. I can have
Okay.
it so that I can connect it with you.
Okay. Okay. Okay.
Right.
Okay. So this is a question one, and the correct option for question one is B. We have seen the detailed solution as well. Okay.
Ma'am, why is it not correct, ma'am? I think it is almost correct only now.
Which one?
B, option B.
Yeah, option B is the correct.
D, ma'am, B, B.
Okay, D, you are
Fourth
asking about.
option.
Okay,
Fourth
so
option.
okay. So already, as I have explained in the option D, that is also a correct option, but it is used. This step is used for decoding. Here, they have asked for every decoded point in a space encoding is identified by the sequence of intensities it receives. So in that case, it is also a correct one. So here I have, that's why I have written. But in the answers, in the assignment questions answer, only B option they have given the correct one, because it is most technically precise and correct option.
Okay, ma'am. But I think like there are some flaws in the theoretical based questions. So because of this, we are losing the external ones.
Yes, exactly what you are saying. Okay, you can, this one, fourth one, D is also a correct one. That's why
Okay,
in the
then.
solution I have written that this is also a correct one. But if you are going to most technically precise, then option B is only. Okay. Okay. So moving to the next question. Now, next question is, which of the following are the examples of the active imaging? Option A, time of flight sensors. Option B, triangulation based sensors. And option C is structured light. Option D is stereo imaging. So already I think you have gone through this. So which option can be a correct? Okay, so A, B, C. Yeah. So time of flight sensors,
A and B, sir.
triangulation. Okay. And structured light. These are the examples of the active imaging. And stereo imaging are the passive imaging. Okay. So A, B, and C are the correct answer for this question because these three are the examples of the active imaging, and this one is related to passive imaging. Okay, so I will go through the detailed solution here. So here, what is it? First, we will see active imaging and passive imaging. So active imaging is the sensor that project its own energy, like light, IR sensors, ultrasounds, etc. So into the sense of measure the reflection to good depth information, while the passive imaging is the sensors that does not emit any energy. It only uses the ambient light or a normal camera. Okay, so time of flight sensors. So TOF works by emitting modulated light, or often it is either IR lasers or LED, and measuring how long it takes to reflect back. So since it emits its own signal or light, it is a active imaging. And then next one is also triangulation based sensor. So it is use the project a laser spot or line in onto an object to calculate depth using geometric triangulation. So it is also emitting a laser or light pattern. So this is also example of the active imaging. So example for the triangulation based sensor, that is a laser triangulation scanners. And now next one is structured light. So a known light pattern, that is either grid, strips or dot, is projected onto the screen. So a camera is used to observe how these patterns deform to a infer depth. So it is also requires the active projection. So it is also an example of the active imaging. Already we have seen studied about the structured light in this week video lectures. Now next one is the stereo imaging. So stereo imaging we have studied in the last is some not a 7, 6 before that. So already we have seen it uses the two or more cameras to mimic the human eyes, how we can see or perceive any object. So it is a example of the only passive because the while the camera is mimic the human eyes, it does not radiate or emit any light. Okay, so the depth is estimated by the find the disparity between these two camera views. No light is projected. It releases only ambient light. So this is the example of the passive imaging. So examples for the active imaging is time of flight sensors, triangulation wave sensor, and structured light. So A, B, and C are the only correct answer for this question. Okay. Okay. So I hope you understand. Now moving to the next question. Now next question is a note it is given. Consider parameterization of the curve by Z UV and it is defined by UV UV. Okay. Which of the following is the first fundamental form of the graph of Z is equal to XY? So any of one of you have any idea how to solve this question? then I will go through that. So what is the first fundamental form? It is a basically first derivative, right? With respect to these parameters like u and v. So how we can represent the first fundamental form of the given of any given. So I'm just writing it here. So the first fundamental form of any given graph is defined by that, let's say it is represented by I. So here E du square plus 2f du dv with plus d dv square. Okay, and where E is Ru into Ru, that means the differentiation with respect to u, that is Ru representative, and F is Ru into Rv, and G is Rv into Rv, that is differentiation with respect to V. Okay, so here given parameter parameterization of the curve is, so now you can
And
find
the
an
both are RU is equal to
which one? It is first one is Ru into Ru, that is first derivative of with respect to u, and in the lecture videos you have gone through the, this is a simple basic representation of first fundamental form. Yeah. So now I have given that this is whole equation, just you have to put by extracting the EFG values into this. So now this is also written. So can you try for this question? How to solve? Just find out the first fundamental form, that is first derivative with respect to u and v, and just first find out EFG and put these values in this one. I'm also solving of the curve is that this is given at z uv is u v and uv, right? Now first we need to find out the derivative, partial derivative with respect to u and v. Partial derivative with respect to u and v. So Ru already I have told that the Ru represented by, let's say, del R divided by del U, or here we can say the del Z. Here it is in the form of Z, so we can write like Z, right? And Z in the form of U and V. So first and RV is del Z with respect to del V. Okay, so just I'm taking on another slide. So first let's find Ru, that is del R divided by del U, that means I mean the Z. So here del U, so our Z is U, V and UV. So we have to derivate it with respect to U only. So you will get here 1, right? Del U divided by del U, so 1 only. And here no U coefficients are there, so you will get 0. And here u only, right? Sorry, v only here, because del u divided by del u will be 1 only, because we are taking the derivative with respect to u. Similarly, you will find out rv also, that is del z. We have to differentiate that del z, sorry, z parameter with respect to v only. So that is del divided by del v, and this value u, v, and uv, right? So rv you will get here no v parameter, so 0, and here 1. Here you will get u. Ru and rv you have already we have computed. Now we need to compute the first fundamental form, that is E, F, and G. Now we need to compute E, F, and G. So already we have seen that E is Ru into Ru. So dot product of the derivatives with respect to U. So what we have got Ru, that is 1, 0, and V. And dot product of 1, 0, V. So here what we will get here, if we take the dot product of these two, simple. So here 1 square, 1 into 1 plus 0, V into V, so V square only. So here you will get 1 plus V square for E, right? Now similarly we need to find out F also. So F is a simple dot product of Ru into Rv, right? So Ru is 1, 0, and V. Our Rv is 1, 0, U. So just take, so 1 into 1 is 1 only. Sorry, here it is dot product of, here Rv is 0, 1, U. Right? So 1 into 0, then plus 0 into 1, U into V. So here you will get U and V only. F. Now next we need to find G. So G is a simple dot product of differentiation with respect to V. So RV into RV. Sorry, dot product is this. So 0, 1, and U, dot product of 0, 1, and U. Right? If you take the dot product of these two, so you will get 0 plus 1 square plus u square. So here you will get 1 plus u square. Now already we have shared one equation. Just put in this one, that is I is equal to E du square plus 2f du dv plus g dv square. Okay, so E is already we know that 1 plus v square, right? Du plus f is uv, so 2uv du dv plus g value is 1 plus u square, that is dv square. Okay, now if you match with the answers, so you will get option C is matching 1 plus v square du square plus 2uv du dv plus 1 plus u square dv square. So option C is the correct answer for this question. Okay, so have you understand? If in this form it is given, so you have to apply this one. Okay, to find out the first fundamental form. Okay, So, any one of you have any doubt, or can we move to the next question? Okay. Now moving to the next question. Yeah, our next question is, which of the following is true about Microsoft Kinect sensor? Option A is uses infrared laser light with the speckle pattern. Option B, if a point is at a higher depth from the sensor, it looks more blurry. Option C is uses the principle of structured light, or option D is all of above. Yeah, someone has already answered, I think. That's what we did. Yeah, correct. Option D is the correct answer for this question. So the all the options for the Microsoft Kinect sensor is correct, that it uses infrared laser light with speckle pattern. If a point is at a higher depth from the sensor, it looks more blurry, or uses the principle of the structured light. So here we will see the detailed answer or solution, its description for this question as well. So first we will see what is a Microsoft Kinect. It is a first version, also known as the Kinect V1. So it is originally designed by Xbox 360 by Microsoft plus PrimeSense. It uses an infrared IR laser emitter that projects a pseudo random speckle pattern of dots onto the scene. That is, so the IR camera captures this pattern and compares distortions to infer depth. That is a structured light technique. And the RGB camera and microphone array are separate components in this one. So this is a basic key detail for the Microsoft Kinect. So our options are based on the uses infrared laser light with speckle pattern. So yeah, already as we have seen, Kinect project a structured IR dot pattern. It is also called speckle into the environment to measure depth. So to measure the depth, it uses the IR dot patterns, or also known as a speckle. So this is one. This one is true. Now next option is, if a point is at a higher depth from the sensor, it looks more blurry. So as the depth accuracy reduces with increasing distance, because the IR dot patterns gets weaker and the disparity resolution decreases. So as we increase the distance of the IR, that laser emitter, so it does not appear, does not able to appear on the scene. So it gets weaker as any object. If we just make some distance from any light, so the light becomes weaker, or we are not able to directly project, that is, so that with the disparity resolution that decreases. So the point at the larger depth appears noisier or blurry in depth map. So this one is also a true. Or our option C is uses the principle of the structured light. Yeah, Kinect V1 is a structured light 3D scanner, and in the later Kinect V2 uses time of flight instead of the structured light. So Kinect V1 uses the structured light 3D scanner. So it is uses the principle of structured light. Okay. So the correct answer all of the above. So here the whole description is there. The Kinect sensor, that is our first generation, uses the structured light to determine depth. Specifically, it projects a unique infrared laser speckle pattern onto the scene, and the camera captures the reflected pattern. The depth is calculated by analyzing the deformation of this known pattern. Furthermore, due to the nature of projected pattern and triangulation principle it uses, points that the further away from the sensor appears less detailed or blurry, effect on the projected speckle spread out of more. So therefore, all the three statements are true. So that's why option D is the correct answer for this question. Okay. Sorry. Okay, so now moving to our next question. Our next question is consider the set of parametric equation that is x is equal to t square plus t and y is equal to 2t minus 1 representing a 2D curve. Compute the tangent vector that is x dash t or y dash t at t is equal to 1. So can you tell what is our x dash t and y dash t? So it is simply derivative or the first derivative of x and y with respect to t, right? So now can you calculate and let me know what will be the answer for this question? Here we are given the two parametric equation that is x and y. So would you like to try for this question?
Yes, ma'am.
Okay, so here I am also solving. You can also solve parallelly. Okay, then we will see. Okay, so here we are given the parametric equation that is
Option B, madam, 3 comma 2.
yes, correct. Option B is the correct. So here I am also solving. That is x t square plus t and y is 2t minus 1. Okay. Now we are asked to compute the tangent vector that is x dash t and y dash t at t is equal to 1. So we need to differentiate create x and y with respect to t first. Okay, so x dash t is represented by dx divided by dt. So here x is given, so d t square plus t dt. So if you just differentiate, you will get 2t plus 1 here. Similarly, for y dash t is represented by d by dt y. So d by dt, our y is 2t minus 1. So here you will get 2 only, right? Now just put find out at because we have asked at t is equal to 1. So here x dash 1 we can say that. So here if you put 1, so you will get 2 plus 1 simply 3. And for y it is if you put, so you will get here 2 only. So x dash, so the tangent vector is vector at t is equal to 1 is 3 comma 2. 3 and 2. These two values. So option C is the correct answer for this question. Okay, so I hope you have understand this question. Now moving to our next question. Our next question is consider parameterization of the curve as a RT, that is xt, yt and zt. This is a representation for the RT. And here the consider 2D parametric curve that is x t cube plus 2t, y is 2t minus 1 and z is 3t. Now again we have to compute the tangent vector as well as curvature for this RT at t is equal to 2. Okay, so here again given the parametrical, now again we have to solve in the same way. So can you calculate it parallelly also? Now next how to compute a curvature we will see. Okay, so till now you can compute the tangent vector. So given curve is that is RT is XT, YT and ZT. It is a representation for RT and X here it is given, or you can say that XT, T cube plus 2T, Y is given 2T minus 1 and Z is given 3T. Okay, or we can represent similarly the RT as a, you can write it as a 3T plus 2T, T cube plus 2T, 2T minus 1 and 3T. Right? Now to find out the tangent vector, already we have seen that. So tangent vector is derivative of the RT. So first we will find out the tangent vector. So it is a derivative, first derivative of RT. Yeah, 14 to 3. Correct, Lavati. So we will move to how to solve for the curvature. Okay. So it is also represent R dash T. Okay. So R dash T R D divided by dt. So our RT is, so if you directly you can do it directly as well also. So T cube plus 2T, 2T minus 1 or 3T. Okay. So if you just differentiate with respect to T, with respect to T here, so here you will get 3T square plus 2 and 2 only, and here 3, right? Now we need to find out the tangent vector at t is equal to 2. So just put that is r dash 2, you can say that we can represent it like that. If you just put, so 3 into 2 square plus 2, here you will get 2 comma 3. So just if you just 14, if you just take multiplication and addition, here you will get 14, 2 and 3. Okay, 14, 2 and 3. So this is our tangent vector. Now we need to find out the curvature. So to find out the curvature, I need to take the one slide here. Okay, so the curvature is is represented by, let's say it's okay. So it is a simple r dash t, that is the first derivative, and cross product with the second derivative with respect to t, and the lower side we will get r dash t cube. Okay, so this is a formula for the curvature. Now already we have find the first derivative with each. Now we need to also calculate the second derivative of RT, because to put in the formula. Okay, now calculate the second derivative as well. So already R dash double dash T is the T square R divided by dt square. So already we have find dr by dt. Already we have calculated one derivative. Now if we need to just calculate the second derivative, so we can say that dy dt into r dash, you can write. So dy dt, our first derivative is 3t square plus 2 comma 3, right? Now, if you again just take one derivation again, so you will get 6t here only and here 0 comma 0, right? Now, if we take r double dash t at t is equal to 2, because they have asked in the question, we need to find the tangent vector and the curvature at t is equal to 2. That's why we are putting t is equal to 2 everywhere. Okay. Now, then you will get r double dash t. So here you will get 12, 0 and 0, right? Our second derivative we have calculated. Now, from the formula, we have to calculate the cross product of the first derivative as well as second derivative as well. Okay, so for this, we are here calculating the cross product of like r dash 2 into r double dash 2. Okay, so I can here write where r dash 2 we have got 14, 2, 3, and cross product this one is 12, 0, 0. So how we can find out the cross product? And for convenience, I am just writing r dash cross product of r double dash. Okay, 2 t I am not writing. I, j, and k. Here 14, 2, 3, 12, 0, and 0. So just we can calculate it like I. So 2 into 0, 3 into 0, minus 3 into 0, minus j, right? And 14 into 0, minus 12 into 3, right? Plus k. So 14 into 0, minus 12 into 2. Okay, so here you will get 0i plus 36j minus 24k, right? And then cross product of these two, you will get here 0, 36 minus 24 if we write in this form. Okay, so now this cross product we have got here. Now we have it is in the mod of, right? So in this form, so we have to calculate magnitude of this cross product also. So just calculate the magnitude as well, because it is here written r dash t into r double dash t. So we have to calculate r dash cross or, so it is calculated, right? So whatever overall points we have got 0, 36 minus 24. So we have to take the mod of this one. So you will get root of square root of this one, right? So 0 plus 36 square plus minus of 24 square. Okay. So if you just take the calculations, so you will get here 1296 plus 576. So if you add all those things, you will get 1872, and here overall you will get 43.27. Okay, you can calculate it by the calculator. Now we need to find out the denominator part as well. The denominator part of the k is denominator. I'm just writing here for the convenience so that you get not confused. Denominator of k, that is curvature. Okay, so here it is r dash t whole cube, right? So just first we will find out the magnitude of that one r dash t. So that means r dash 2. So what is our r dash 2? This is 14, 2 and 3. So we have to take the mod of that one. So here you will get 14 square plus 2 square plus 3 square. So if you just calculate it, so you will get 196 plus 4 plus 9. So overall here you will get the root of 209, and this is equal to 14.456. Okay. So now it is a, in the denominator it is a of r dash t cube. So just take a 14.456 cube. So you will get here. What will be the value we will get here? So overall you will get here 3020.956. So just put in that formula all these values. So curvature, that is represented by this one. So it is our r dash cross double this one divided by r dash cube. So we had calculated this value and this value. So here it is a 43.27 divided by 3020.956. So if you could just calculate it, so you will get 0.01432. Okay. So basically this is our curvature, but it is does not matching with any of the other option. I have calculated many other ways itself, but it is so here the option is just if you multiply with this some values or 100, so approximately you can get here 14.32. You just multiply by 100, so it is approximately equal to 17.76. So basically the option B is the correct one, because option one, the tangent is matching but curvature is not exactly matched but approximately. No other values are nearby this one. So that's why option B is correct option. Otherwise, this one is incorrect. Basically, it is 0.01432 here you will get. Okay. So either we can correct it. Okay, you will get the correct answer here. Okay, but this is how you can calculate the curvature. Okay. So option B is the correct one. Anyone have any doubt? Yeah.
Hello, ma'am. So, I want to know if I want to remember this formula, how can I remember this? Like, what is the reason due to which this it's formulated like this? Like, first derivative multiplied by second derivative, and then we take the mod of that
Okay,
value.
so it is a standard formula already. It is not, I mean, you can just remember it is a, to find out the curvature of any surface vector or any curve. So
Okay.
this is a standard formula, this one. For any curve it is given to find out the curvature as well as tangent. This is a cross product of first derivative and second derivative, and the denominator, that is a mod of first derivative cube. Okay,
Cube. Okay.
yeah. It
Because
is a,
it's related to 3D reconstruction, right?
yeah, yeah, it is related to 3D reconstruction.
Okay.
Okay, so I hope all of you understand this question. Now, moving to our next question. So our next question is compute the normal vector to the surface given by SUV, that is XUV, YUV, ZUV, and where XUV is UV is equal to U and YUV is equal to 2V square and ZUV is equal to U square plus V square. It is given. Okay. So now we need to compute a normal vector. So how we can compute a normal vector? So for any given surface or this type of vector, to compute a normal vector, it's basically here the cross product of the partial derivative with respect to u and v. Okay, so it is simply the represented relates is u comma v, that is a s u cross product of s v, where s u is del s divided by del u and s v is del s divided by del v. Okay, so normal vector is represented by this one, and where s u v a simple first derivative or partial derivative with respect to any given surface. Okay, so here our given function is, that is s u comma v, that is in brackets x uv y uv and z uv, and here it is x uv is given as u, y uv is given as 2v square, and z uv is given as u square plus v. Now we need to take the partial derivative of s with respect to u and v, and then find out the cross product of these two. Okay, so first del s divided by del u, that is represented as su in this one. So if you just derivate with respect to u only, so here you will get 1, here it is 0, here you will get 2u, right? Now if you just derivate with respect to v, it is also represented by s v. Okay, where it is a u. So here you get here 0, here you will get 4v, and here you will get 1, right? Now to find out our normal vector, we need to take the cross product of these two. So how we can find out the cross product? Already we know that, that is I, j and k, right? So here 1, 0, 2u, here you will get 4, 0, 4v, 1, right? Just calculate it, I, j and k values, and again write in that form. So here I is 0 minus 8 uv, right? Minus j is 1 minus 0, right? And plus k, where it is 4v minus 0. So after that, just I'm writing it here. So here you will get minus 8 uvi minus j and plus 4vk. And the cross product overall in that form is represented minus 8 uv minus 1 minus 4v, right? So this is a representation of the normal vector basically. Now it is given as in this form. That means they have, in the question they have not given any value. That, for example, in the previous question they have said that find out at t is equal to 1, t is equal to 2, something like that, but no values here they have given. But now we have to put the values and just match with the options which can be a correct one. Now here we have to take the values that will be fit into this one. So all the basic equation we have got for the normal vector. Now we have to take or put the values of uv in the some questions they will be giving the uv values, that like you have to take u is equal to 1, v is equal to 2, something like that one. and now match with the answer. So basic, you have got either it can be represented, otherwise we can just, if you just do it opposite to 8 you will get 1 here minus 4v. So just check with this one. So here first I and j term both are minus and k term is positive. So just check with the answer. No, just took the opposite. Just multiply with the minus sign. So you will get first two components are positive, next one is negative. So it is in C is in that form, right? You can do in that way also. Just we need to find out the correct u and v value. It is in that case. So what values we can put here for u and v? Okay, b, if we put b is equal to 1 and u is equal to 2. Okay, yeah.
B
So
equal
it
to
is,
minus.
yes,
B equal to minus.
yeah, we just exactly your voice is not clear. So just we can take first u v is equal to 2, both is equal to 2, and just check with options can be a correct one. Here first and second term both are the minus. Okay, so either you can take this one or this one. So if you take both, so no option will be match here, right? Because the first two terms are not negative in any of the options. So you can just take the opposite one. That means multiplied with the minus. So you will get first two terms are positive and the last term will be the negative. So if you check with that way, so you will get option C is the only correct answer for this question without putting any values. So yeah, correct. You have said that if we take u is equal to 1, v is equal to 2, then we will get the answer. So let's put that values. So if you put u is equal to 2, v is equal to 1, then you will get answer C is the correct answer for this question. Okay, if values are given, then you can directly put. If it is not given, so already we have solved many this type of questions in our previous classes or previous days, our early 11, 12 classes. So there you can see that we are taking this type of problems. Okay, so where I can remove it, so we can put the values. So I'm just removing it from here. Okay, so if we assume u is equal to 2 and v is equal to 1, then I'm putting it in this one. So you will get 8 into 2 into 1, 1 and minus 4 into 1. So here you will get 16, 1 and minus 4. So in that case, option C is the correct answer for this question. Okay. If you are not taking any value, then in that case also, just you check with the signs, we'll go through the different signs, then you will get to know. Option C is the only correct answer for this question. Okay. Okay. So have you understand this question? Then we move to the next question.
Yes, ma'am.
I have one question.
Yes, yes.
So this normal vector to the surface, is it similar to the tangent?
You can say that. But basically, it is the normal vector is the cross product with respect to u as well as respect to v. So in the tangent vector, we are not taking the, I mean, cross product, I think. There is a dot product.
Okay.
Mm. Just remember these few small point. There is a dot product and cross product. Okay.
Okay, got it. Thank you.
Okay. So now moving our next question. Our next question is the theoretical one. So which of the following statements are not true for the detection of the edges in the range image? Option A, roof edge points are detected from zero crossings of Gaussian curvature. Option B, step edges points are detected from zero crossings of the Gaussian curvature. Option C, step edge points are detected by the extrema of the dominant principal curvature corresponding to its direction. Option D, roof edge points are detected by the extrema of the dominant principal curvature corresponding to its direction. So, but here in the question, just see the question. Which of the following statements are not true? Okay, they are not asking about the which options are the correct. They are asking which options are the not correct. Okay, and for the region is detection of the edges in the range image. Okay, so just remember this one. This they are asking which statements are not true. Okay, so we have to find out the incorrect statement. So can you see and give me the answer which option is not a correct one? That is roof edge points are detected from zero crossing of the Gaussian curvature, or the vice versa, step edges points are detected from the zero crossing. And similarly for these two. So okay, let's see the detailed solution for that one, otherwise we are not able to complete our questions. Okay, okay, so our solution, first see what is a step edge and what is our roof edge. So it's step edge is also called as a jump edges. So jump edges in the range image produces zero crossing in the second order surface measure. That is example is Gaussian curvature or Laplacian light curvature. This is a second order derivatives. So in practical papers on range image edge extraction, step edges are detected from zero crossings of the Gaussian curvature. They show zero crossings often flanked by the opposite signed extrema. Similarly, for the roof, also called as a ridge or valley edges, are the type of curvature features which where one principal curvature reaches a local extremum along with its principal direction. Therefore, roof edges are found from extrema of the dominant principal curvature, not from the Gaussian curvature zero crossings. Okay, so let's see from the option. It's option A says roof edges detected from zero crossings of the Gaussian curvature. So it is a false. Roof edges corresponds to a curvature extrema, not a zero crossing. Okay. Now option B, that means that is a correct true one because it is just opposite to the option A. So it is a step edges detected from the zero crossings of the Gaussian curvature. So this one is a true, but option A is that means false. Now option C, it says step edges detected from the extrema of the dominant principal curvature. So it is also false. That method finds a roof or edges features not a jump. Okay. So option D is roof edges detected by the extrema of the dominant principal curvature. So that's true. So they have asked that which option is incorrect. So option A and C are the incorrect option. That is not true. Okay, option A and C are the not true statement. So here our answer is option A and C are the not true or incorrect statement for the detection of the edges in the range image. Okay, these are the correct statements, option B and D. Okay, so now moving to the next question. Our next question is, which of the following statements are true regarding the surface type consideration, considering the signs of their curvature at K1 and K2? Option A is peak surface if both K1 and K2 are negative. Option B is saddle surface if both K1 and K2 are positive. Option C is ridge surface if any one of K1 or K2 is zero and other is negative. Or option D is pit surface if both K1 and K2 are negative. So which statements are the true on the following options? So it is regarding the surface type consideration the signs of their curvature K1 and K2. Okay, so these are the basic questions which we have studied in our early graduation years. Okay, let's go to the solution. Then we will see which options can be a correct one. So here explanation is for that. This question is here. Let K1 and K2 be a principal curvature of the surface point that is used to quantify. So let's say it is a Gaussian curvature. Let's assume that. So for a height function, let's say z is equal to f x comma y with the usual upward orientation sign of the Hessian, that is Hessian is a second derivative that matches sign of the principal curvature locally. So if Hessian negative definite, so both principal curvature are negative, that is the local maxima peak. Okay, if both the principal curvatures are negative. If both the principal curvatures are positive, then you will find the local minima that is fit. So if you have gone through this week, this type of here, it is a local minima that is fit and local maxima that is a peak, right? This type of so different functions produces a different type of in their derivatives, different type of functions or Gaussians. So this is one. If Hessian with mixed, that is K1 and K2 less than 1, so there is a saddle point in the Gaussian curvature. Okay. So if one curvature is zero and other is non-zero, so surface flat like this one and flat in one principle, that is ridge, flat or valley in that case. Okay. So let's go through the options as well. Peak if both K1 and K2 are negative. So if you see the example for the derivatives of this function, minus of x square plus y square has a second derivative negative, that is in the negative sign in the both direction. So that will produce the local maxima. That is true. Saddle if both K1 and K2 are positive. So this one is false. You get a saddle point if one of them are negative, another one is a positive. So not if both are positive, so you will get a local minima. Okay. So both positive gives local minima, that is fit, not a saddle point. Okay. So as saddle requires opposite signs, one is positive, one is negative to produce a saddle point. Option C is ridge if one curvature is zero and other is negative. So it is also true. So you can take the another example, z is equal to minus x square, that is independent of y, has a principal curvature minus 2 and 0, curved or in a concave form in x direction and flat of y direction in the ridge like point, depending on the convention of a 0 with the positive other curvature in the flat valley and negative non-zero curvature of the ridge. So that is a true. And pit if option D is pit if both K1 and K2 are negative. If both are negative, so already we have seen in the generalized form, if both are negative, you will get a local maxima, peak, not a peak. Okay. So here it is summary one is given. If K1 and K2 both are greater than, that means positive value, then you will get a local minima, that is peak. And if K1 and K2 both are positive, we will get a local maximum, that is peak. If any one is positive, one is zero, something like that, so you will get flat value or saddle point. So option A and C are true, while option B and D are false. Okay, A and C are true, option B and D are false. Here, okay. So they have asked about the true statements. Option A and C are the true. Okay. Okay. So I hope you have understand this question. Now, moving to our next question, choose the correct options regarding digital neighborhood plane for 3D neighborhood of a point P. Okay. So the option A is number of principal planes are 3. Option B is number of diagonal planes are 6. Total number of digital neighborhood planes are 9. And option D is total number of digital neighborhood planes are 8. Which options are correct regarding the digital neighborhood planes for a 3D neighborhood of a point P? So any one of you have any idea regarding this question? Okay, see. Yeah, okay. So here multiple options can be a correct one. Okay, so let's see. So firstly, what is digital neighborhood planes? So digital neighborhood planes in a 3D neighborhood of a point, that is P, X, Y, Z. It is the idea that in a 3D digital grid like occurs in image processing, the neighborhood of a point is defined not only the axis aligned direction but also by a diagonal planes through the point. Okay, so what will be the principal plane? So there are the planes aligned with the coordinate axis. At any point of P, there are three mutually perpendicular principal axis plane. One is if three planes are in the three directions x, y, z. So in one is the xy plane, another one is parallel to the yz plane, zx plane. So total how many principal planes will be there? Three principal planes are there. And now next we will move to the diagonal plane. So apart from the axis aligned the planes, we are also form the planes by taking diagonals of the coordinate axis. For each pair of the coordinate axis, there are two diagonal planes. For example, for xy axis or xy plane, there is x plus y and x minus y. Similarly, for yz and zx, y plus z, y minus z, z plus. So total six diagonal planes will be created there. So three principal x planes and the six diagonal planes. Okay, if three principal planes are given, so for each corresponding principal plane, there are two diagonal planes will be created. Okay, so now total number of digital neighborhood planes will be the principal planes plus diagonal planes. So total 3 plus 6, 9. So total 9 neighborhood planes are there. So let's go to the option. They have asked number of principal planes are 3. That is, this one is correct. Number of diagonal planes are 6. That is also correct. Total number of digital neighborhood planes, that is, we have got a 9. So option A, B, and C are three options are the correct, not option D. Okay. Okay. So I hope all of you have understand. So can we move to the next question hour?
Yeah, so in this
Yes.
question,
Yeah. Yeah.
uh, if you go back to the previous slide, I just want to
Yeah.
check that. Yeah, because choose the current option regarding
Correct
the
options.
correct options
Yeah.
regarding.
Yeah. Regarding
Okay,
digital neighborhood plane. Yeah.
okay, got it.
Okay. Yeah. Okay. So now moving to our next question. Our next question is consider the coefficients of the first fundamental form are given by A is equal to 5, capital F 1, capital G 3, and the coefficient of the second fundamental form that is given as small e, f, and g, that is given 3, 7, and 3. Now they have asked for compute the Gaussian curvature k. Okay, here the fundamental, first fundamental and second fundamental forms are given. Now we have to compute the Gaussian curvature. So you must have gone through this type of question in the exercise questions, I think, in the lecture, video lectures week. So we will solve it here as well. So here first fundamental forms, E, that is 5, F is 1, and G is 3 is given. And the second fundamental form, that is E is equal to 3, F is equal to 7, and G is equal to 3 is given. So a Gaussian curvature, there is a formula already is given, is defined as curvature, that is K is defined by, and just writing that formula, you can directly learn it, or otherwise you can also, so it is E G minus F square, and it is EG minus F square. For your remembering purpose, here I am writing that where it is derived from. So if you have gone the video lectures, so you must be gone through this matrix E F and G, and here it is a E F F G, right? Inverse. So from this formula is derived from this one. Okay, you must be gone through this one, this matrix function. Otherwise, you can directly also just take a determinant of that one. And this one is inverse. So if you just, so it will come to the denominator. Okay. So have you understand this one? So just all values are given. We need to put and find out the what will be the value of Gaussian curvature. So let's put in the, so small e is given 3, small g is also given 3. So 3 into 3 minus f square. So 7 square. In the denominator we have eg, that is 5 into 3. 5 into 3 minus 1 square. So in the numerator you will get 9 minus 49, right? In the denominator you will get 15 minus 1. So here you will get minus 40 divided by 14. So if you further divide it, you will get minus 20 by 7, right? So if you just see Gaussian curvature K, you have find minus 20 by 7. So option B is the correct answer for this question. Okay. Okay. So this is a direct formula based question. So I hope you have understand this question. Now moving to the next question. So our next question is again given from this one also. So here consider a hyperbolic paraboloid represented as a parametric surface x uv, that is u, v, and comma uv, with u is given as 3t square plus 2t and v is given as 2t plus 1. Compute all the first fundamental form coefficient at t is equal to 2. So now we have to compute the first fundamental form, that is E, F, and C, right? The function is given. Now, how we can compute the EFG? Already we have seen in the previous question, but there we have not described or not just taken it as represented by EF and G. We have just taken another form. Okay, so let's find out how we can compute the first fundamental form from the given equations or functions. Okay, so the surface function that is given as x u v, that is u v and u v, and u and v is also given. Now the first fundamental coefficient, already we have seen that. First, how to determine fundamental form coefficient, that is e. So already we have seen in the, we are just multiplying the first derivative with respect to u and v. So this one x, first derivative of the with respect to u, and their dot product, first derivative of with respect to u, and f we are representing x u into x v, right? And g is x with respect to first derivative with respect to v. It is a simple representation way. Now first we need to find out the first derivative with respect to u and v. So that is x u. So it is del x divided by del u, right? So just del divided by del u. So u v u v, right? So if you take the first derivative of this one, you will get 1, 0 and v, right? Similarly, for x v, you can determine the first derivative with respect to v. Okay, so just take the derivative with respect to v. So u v u v. So here you will get 0, 1 and u, right? Please unmute yourself or mute yourself. Okay. Okay, xu and xp we have determined. Now we can determine the e, f and g values as well, right? So e already here it is xu into xu, dot product of these two. So 1, 0, v, and again dot product of 1, 0 and v. So e you will get 1 plus 1 square plus 0 square plus v square. So overall you will get 1 plus v square, right? Similarly, you can calculate f also, x u dot x v. X u is 1, 0 and v dot product with 0, 1 u, right? So f, if you calculate, you will get u v, all the product, these are the two, f you will get u v. Similarly, you can calculate for g. So g is x v into x v. So here you can just 1, 0, here it is u. Similarly, dot product 1, 0 and u. So if you just multiply, you will get 1 plus u square, right? Now, the u and v values are also given. That is u, we have to take this also, u is equal to 3t square plus 2t and v is equal to 2t plus 1. Now they have us compute all the first fundamental form coefficient at t is equal to 2. So E, F and G we have got in the form of U and V. Now we have to take this one also. So, okay, so on then I will take the another slide so that otherwise I have to remove it from here. Okay, so we need to evaluate these coefficients at t is equal to these coefficients at t is equal to 2. So u and v is already given as a function of t, that is u is given as I lost my pen again. So till now we can calculate the u and v values. Here u is given as a 3t square plus 2t in the questions. So can at now we need to find u at t is equal to 2. So just put the t is equal to 2 in u and v. Then we need to compare with this one. So already know that it is given in the question u is equal to 3t square plus 2t. Now we need to put u at t is equal to 2. So if you put 3 into 2 square plus 2 into 2. So you will get total 3 into 4 plus 4. So here you will get 16. Similarly, we need to calculate for v. Also, v is given in the question, that is 2t plus 1. Now we need to calculate v at 2. So 2 into 2 plus 1. So it is equal to 5. Now we have calculated u and v values. Okay. Now substitute these u and v values into E, F and G, what we have calculated previously. So E we have calculated, that is equal to 1 plus v square, right? Here 1 plus v square, F is uv and G is 1 plus v square. So now put the value of v here. So 1 plus 5 square. So you will get 1 plus 25. You will get total 26. Value of E. Similarly, just calculate for F also. F is U and 2V we have calculated. So here U is 16 and V is 5. So 16 into 5. How much we will get here? 80. Right? And G. Similarly, G 1 plus U square. This is a value. So just put the values 1 plus 16 square. So here you will get 1 plus 256. So you will get 257, right? So E value you have got 26. F value we have calculated 80 and G value is 257. Okay, so this is our answer. So let's check in the options. E is 256, F is 80 and G is 257. Okay, basically no option is matching because G is not matching, I think. Yes. E is 26, F is 80 and G is 257. So option B is the correct answer, that is none of above, none of these answers. So this is how we are calculating the values of E, F and G, which is directly given in our previous question. Okay. Okay, so I hope you have understand this question. Now moving to our next question. Okay, so next question already here it is given and formula is also it is given. So can you calculate it directly? Now all the values are given, mean curvature is given, the formula is also, and the correct answer is also given here. So mean curvature is computed the coefficient of the first and second fundamental derivative, that is it is this one, h is equal to EG plus GE minus 2FF divided by 2 EG minus F square. So here all the values are given. Now we have to compute the mean curvature H. So just put the all values. E is given as 2. G capital small g is given as a 3 plus capital G is given as a 7 and small e is given as a 4, right? minus 2, capital F is given as 3, but small f is given as 0. Now 2, 2 into 7 minus capital F square, that is 3 square. So can you just calculate it, these values? So already solution and correct answer is given. I forgot to just remove it. So just calculate it. So here you will get 6 plus 28 minus 0 divided by 2, 14 minus 9, right? So 28 plus 6 is 34. If you just 14 minus 9 is 5. 5 into 2 is 10. So here you will get 3.4. So they have our answer up to 2 decimals, but here, so you can just put it 0. So option B is the correct answer for this question. Okay. Okay. So this is a simple question and everything is given here, so you can solve it. Already I have solved it here. How to solve it? Just by putting these values. So option B is this answer. Now move to the next question. Our next question is, in range image processing, what is the significance of the first fundamental form? So options are, it describes the intrinsic geometry of the surface independent of how it's embedded in 3D space. Option B is, it measures the curvature of the surface at a given point. Or option C is, it relates the surface coordinates to the object's color. Option D is, it helps in detecting step edges by finding zero crossings. So which option can be a correct one? In range image processing, what is the significance of the first fundamental form? So let's see the detailed solution for that one. So solution is, the fundamental form is a mathematical tool that measures distances and angles on the surface. It is a key concept in differential geometry and is used to analyze the surface properties without considering its embedding in a higher dimensional space. So the first fundamental form of coefficients, that is E, F and G, are used to compute distances and angles on the surface. So basically it describes the intrinsic, and this is related to intrinsic geometry of the surface independent of how it's embedded in 3D space. So option A is the correct answer for this question. The significance of the first fundamental form is, it is related to the geometry of the surface and it is not dependent on how it's embedded in the 3D space. Okay, so this is a basic question. Now moving our next question. Now next question is, if a structured light system projects a known pattern of an object, if the horizontal shift of a projected point is measured as 5 mm and the system calibration factor is 0.25 mm per pixel, what is the pixel disparity? So how we can calculate a pixel disparity of a structured light system? So here, given the horizontal shift of a projected point is 5 mm and calibration factor is 0.25. So disparity of a pixel, or you can say that in pixels, is calculated by this formula. Shift in millimeter divided by calibration factor. that is in millimeter per pixel. So total we will get in pixel. So horizontal shift is given as a 5 millimeter, and the calibration factor is given as 0.25. Right? If you just divide it, you will get 20 pixels. Right? So here the option C, that is 20 pixels, are the correct option. So if they ask about the pixel disparity for the structure type, so this is a simple formula, that is shift divided by calibration factor, that measures the pixel disparity. Okay. Now moving to our next question. Now our next question is, in a LiDAR system, the pulse return time is 15 nanosecond if the speed of light, that is the predefined c, is equal to 3 into 10 to the power 8 meter per second. What is the distance to the object? It is also used, we have used or we have studied. So how we can calculate the distance if these values are given? Anyone have any idea? You have studied about this one. Okay, so for any system where we are sending the light and then it is returned back to the object, then we will find the what is the distance of any object. So this can be other system also. We can calculate, this is a basic formula to calculate the distance, that let's see, it is represented by d. It is a c into t divided by 2. So here this is 2. This is because of the round trip, because it is going and then just uh, then in that case, if light we are sending and it is just distracted with the any object, and then it will return back to that system. So there is a round trip, just going then return back. Okay. So this divided by 2 because of round trip, because of round trip, because it going then it is return back to that system. So that's why it is divided by 2. Okay. So here C is given already, 3 into 10 to the power 8 meter per second, and the T, the pulse return time, is 50 nanosecond, that is 50 10 to the power minus 9 second. Okay. It is also given, then distance D is calculated by C, that is 3 into 10 to the power 8, and that is T, 50 into 10 to the power minus 9 divided by 2. Okay, so if you just do that, so here you will get 15 divided by 2, and overall you will get 7.5 meter. Okay, so total distance you will get 7.5 meter. So option A is the correct answer for this question. Okay, so have you got this question? So anyone of you have any doubt, or we can move to the next question? Okay, so now moving to the next question. Our next question is, a range image contains 640 into 480 pixels. Each pixel represents depth in meters stored as a 16-bit integer. So calculate the total memory required for storing the range image. So it is a memory related problem. So how we can? So first we need to calculate what is the total number of pixels. Then just multiply it by 16-bit because it is stored as a 16-bit integer. Then just convert it into the byte. So already we know that 8 bits equal to 1 byte, right? Here 16-bit integer it is. So that means 2 byte, right? So a range image that is image contains total number of pixels, that is 640 into 480 pixels, right? So if we multiply these two, so you will get a total number of pixels. If you multiply, you will get 307200 pixels. Okay. So now this is used to store 16-bit integer, right? So the total memory required to store 16-bit integer in that form, so it would be 307200 into 2. That represents the each 16-bit represented by a 2 byte. So that's why we have directly converted into 2 byte. Then it is easy to calculate in the form of byte and kilobyte. Okay. So if you just multiply, you will get 614,400 bytes here, not in the pixels or something else or bits. So if you just do that, so you will get 614.4 kilobyte, right? KB. If you see, option B is the correct answer for this question. Okay, okay. So I hope you have understand these questions. So now again moving to our next question. Our next question is a structured light system projects a pattern with 64 distinct steps. What is the minimum number of binary patterns required to encode these steps? So you have studied about this and we have solved one theoretical question based on that in the binary encoding system. Very first question, there is 2 to the power n total number of distinct pattern that we have got. Okay, I can write it here. It is, so what will be the solution? What will be the n total? What is the minimum number of binary patterns required to encode these strips? Okay, I'm writing here. Binary encoding system encoding structured light system, the number of distinct patterns that can be encoded is 2 to the power n. Already we have seen, and where n is the number of projected patterns. So to find minimum number of patterns, that is n, 2 to the power n must be greater than or equal to 64. Here, because it is given a structured light system projects a pattern with 64 distinct patterns. So it should be 2 to the power n or is equal to, so 64 we can represent that 64 to the power 6 itself, right? 2 to the power 6 is equal to 64, right? If you just, so n, what we have got, n is equal to 6, right? So the minimum number of binary patterns required to encode these strips, that is n is equal to 6. Okay, so option B is the correct answer for this question. Okay, so I hope you have understand this question. So now moving our next question. Okay, so our next question is given the coefficients of the first fundamental form E, F, and G and second fundamental form E, F, and G in small, compute the Gaussian curvature. Already we have solved one question in this. So can you solve and let me know what will be the answer for this question? So the Gauss formula for the Gaussian curvature, I can write it here and just can you calculate and let me know. K is calculated by E G minus F square divided by E G minus capital F square. So just put all the values. So E here it is given to G is 6 minus cap small f is given 1 square. Capital E is given as 4. Capital G is given as 5 and now capital F is also 1. So 1 square. So if you 12 minus 1 here, 20 minus 1 here. So overall you will get 11 by 19. Okay. The Gaussian curvature K you will get 11 by 19. So option A is the correct answer for this question. Okay. Okay, so our next question is related to our previous class because in the previous class I was not able to solve. Hello, are you able to listen me? maximally saturated color in XY chromaticity space, preserving the same hue and intensity for the given point 0.29, 0.21 in the XY chromaticity space. So just a minute. Okay, so here given primary colors R, G and V is given in the XY chromaticity space, and one we have white space that is 1 by 3. 1 by 3 that is already predefined, and it is. So now first we need to use, to compute this one, we need to use the projective space. So first we need to represent all the points in projective space. So already R is given as, already told you, 1 by 3 and 2 by 3. G is given as 3 by 4 and 1 by 5, and B is given as 1 by 10 and 1 by 6. To represent it in the projective space, already we know that it is 1 by 3, 2 by 3, 1. G is represented by 3 by 4, 1 by 5 and 1, and B is represented by 1 by 10, 1 by 6 and 1. Right? The other points that is given, the white point is represented in the projective spaces 1 by 3, 1 by 3 and 1, and Q, this is the intensity of the given point that is represented by Q, is also 0.29, 0.21 and 1. Okay, so this is a projective space representation of these points. These points. Now to calculate the chromaticity space preserving the same hue and intensity, we need to calculate the other parameters as well. Okay, so first we need to find out the different component, that is RG, then GV and BR. Okay, so first calculate the R into G. There is a 0.33, 0.667 and 1. If you just convert and take a cross product for 0.75, 0.2 and 1. So it is a basically, when we can write it like this one also, 1 by 3, 2 by 3, we can represent 0.33, 0.67 and 1, right? It is also, if you just divide it, 0.75, 0.2 and 1, and this V is represented by 0.1, 0.667 and 1, right? So that's it for easy calculation, we have just converted it. So take a cross product of these two. So if we take the cross product of any of these two A cross B, so different components related to X, Y and Z, or you can say I, J and K also. If you take cross product of any A cross B, that is represented by I, J and K, then A1, B1, C1, here A2, B2, C2. This is related to X component, Y component and Z component. Okay. So for that, similarly we can calculate for this one also. So R into G, so 0.33, 0.6671, similarly 0.75, 0.2 and 1, right? So here you will get the first one I, you will get 0.667 into 1 minus 0.2 into 1, right? Minus J, you will get 1 into 0.75 into minus 1 into 0.33 plus K, here you will get 0.33 into 0.2 minus 0.667 to the 0.75. So here overall you will get, here if you just divide and subtract it, 0.467I minus 0.42G plus if you just divide it here, you will get 0.433 K. Okay. Yeah, for R into G, you will just, if you extract it, you will get here 0.467, here you will get 0.42 and here you will get 0.433, here minus you will get, if you just take a opposite one, so 0. Here you will just here you will get minus. Here you will get a positive sign. Okay, so just do that. So here you will get the positive sign and here you will get minus. Okay, if you just calculate it. Similarly, you can calculate for G cross B also. So G cross B is 0.75, 0.2 and 1 multiplied by 0.1, 0.1667 and 1. Similarly, for that R G into B, you will get the value 0.033 minus 0.65 and 0.105. Okay, so let me check mass variety. My Chrome is hanging, that's why I'm just directly teaching it. Okay, and similarly for B into R, you will get the values minus 0.5, 0.23 and 0.01. Similarly, we have to calculate with W and Q also. W and Q, for that you will get the value 0.1233 minus 0.0433 and minus
0.02667. So now we need to find out the intersects WQ with each edges. Now we need to find intersects with each edges. So first intersect we need to find GB into WQ. So GB we have got 0.33 minus 0.65 and 0.105, cross product with 0.1233 minus 0.0433 minus 0.2667. Right, if you take the cross product of these two, so here you will get total minus 1313 divided by 1000 minus 2491 divided by 18, and here you will get minus 141417 divided by 18,000. Okay, now if you convert back to the normal space, back in normal space, so that is x, that is this one minus 1313 divided by this, divided by minus 1417 divided by 18,000. Here you will get 0.2779, and for y this one you will get minus 2491 divided by 18,000 divided by 18. So here you will get 0.176. So for this one, the intersection point for these two, you will get 0.2779, 0.176. Similarly, we need to calculate for RG into WQ. So here you will get 0.417 and 0.572, and for BR into WQ, here we will get 0.807 and 1.682. So this is outside from the chromaticity range. Chromaticity range, because of it is greater than 1, so it is removed. So these 2 points are in the chromaticity range, so just this is the best chosen option for the chromaticity range, so that's why option C is the correct answer for this question. Okay, so this is left question from the week 8. So here end of our questions. Okay, so thank you everyone for joining this session. I hope it is helpful for you.